Hi, once again, welcome to Varenya's Photon Online Educational Academy for IIT and NEET examinations. This is Guntuka Srinivas. This channel especially focuses on the basic concepts associated with physics, chemistry, and mathematics subjects for the preparation of IIT and NEET examinations. In this session, I welcome you all for the IIT chemistry classes. In this session, let us concentrate on the concept of mole. Let me take up mole concept. Mole concept. Clear? Now, the basic question, fundamental question arises is, what is mole? What is mole? Mole is a number. Mole is a number. Of the clarity, mole is a number. One mole is equal to 1 mole is equal to 6.022 into 10 to the power of 23. Very, very important. Observe this. 1 mole is equal to 6.022 into 10 to the power of 23. That means the 6.022 into 10 to the power of 3 quantity, this much quantity is equal to 1 mole. Clear? So many units, so much quantity, so many numbers is equal to 1. And this so-called number is known as Avogadro number. Avogadro's number. This quantity is known as Avogadro. Is it clear? Mole is nothing but a number, and that quantity, 1 mole is equal to 6.022 into 10 to the power of 23. And this particular quantity is known as Avogadro number. Avogadro is the scientist, and after his name, the number came. That is the Avogadro number. Clear? Now, before going into the details of the mole concept, let us concentrate the fundamental aspects of an atom. If I take an atom, I am magnifying. This is nucleus. This is nucleus. Here I show. This is nucleus. Okay. And in this nucleus, you will be having protons. P stands for protons. and N stands for neutrons. N stands for neutrons. In the nucleus of an atom, we take the entire atom as an entity, and in the atom, the central core part is known as nucleus, and in the nucleus of an atom, there is the existence of protons and neutrons. P stands for proton, N stands for neutron. Clear? And surrounding this nucleus, there are orbits. This is orbit. Okay. And in these orbits, this is orbit. In these orbits, electrons move around. All these are the electrons. Electrons move in the orbit. Clear? So, electrons move in an orbit around the nucleus. And in the nucleus, there will be the protons and the neutrons. Here I clearly write. Here I clearly write where P stands for proton and N stands for neutron. Clear? E stands for electron. E stands for electron. Clear? Now, observe carefully. Mass of proton is denoted as M subscript P. M is the capital letter, P is the small letter, M subscript P, mass of proton, which is mass of proton, which is equal to 1.67 into 10 to the power of minus 24 grams. G stands for the grams. 1.67 into 10 to the power of minus 24 grams. Clear? And observe this mass is known as 1 atomic mass unit. 1 atomic mass unit. In the short form, atomic mass unit is represented as AMU. The short form, it is AM. That means entire mass of proton, MP, is equal to 1.67 in 10 to the power of minus 24 grams. And that entire quantity is equal to 1 atomic mass. 1 atomic mass. Clear? Okay. Now, let us take up the mass of proton. Already we have seen mass of neutron. Mass of neutron, which is equal to, denoted as capital Mn. M capital letter, N is the small letter notation, which is equal to almost the same quantity we are taking. This is also 1.67 into 10 to the power of minus 24 grams only. G stands for the grams. And always remember, Mass of neutron is slightly more than the mass of proton. Mass of neutron is slightly more than the mass of proton. Here I clearly write mass of proton, mass of proton here, mass of neutron, mass of neutron is slightly more than mass of proton. Clear? Have that clarity. Mass of neutron is slightly more than the mass of proton. But for all practical purposes, we take mass of proton is equal to the mass of neutron. That's why we have chosen here the same quantity. Both are of the same quantity. Clear? And remember, this quantity is also equal to 1 AM, 1 atomic mass, 1 AM. First we have taken what? First we have taken the mass of proton, this much. And second we have taken mass of neutron. Mass of neutron is slightly more than the mass of proton. But for all practical purposes, we take the mass of neutron is equal to mass of proton, same quantity. That is also 1 atomic mass, 1 AM. Clear? Both for calculation purpose, both are of the same quantity. Clear? Let us take the third thing is that third thing. Mass of electron, which is equal to ME, mass of electron, which is equal to ME, which is nothing but that quantity is equal to 9.1 into 10 to the power of minus 27 grams. G stands for grams. 9.1 into 10 to the power of minus 27 grams. Clear? That is mass of electron. Is it clear? And remember always, mass of electron is less than the mass of proton. Mass of proton is less than that of the mass of neutron. Clear? Okay. Mass of proton, here I clearly write. Mass of electron, ME, is less than the mass of proton, MP. Clear? And already we have seen mass of neutron is more than the mass of proton. That means if an orderly, if we place, mass of electron is least, and then comes mass of proton, and mass of proton is less than the mass of neutron. Neutron is having some larger mass, but for practical purpose, we are taking mass of proton is equal to mass of neutron. Clear? And remember that mass of electron, Me stands for, M stands for mass, E stands for electron, subscript E stands for electron. Mass of electron is always 1 by 1837 of mass of proton. Have the clarity. Mass of electron is 1 by 1837 of the mass of proton. That means proton is having more mass compared to the electron. Is it clear? We have discussed what are the parameters. We have discussed here about the mass of proton. We have discussed about the mass of proton. We have discussed mass of neutron. We have discussed mass of electron. Three things we have concentrated: proton mass, neutron mass, and electron mass. Clear? So we have also seen that in the nucleus, protons and neutrons will exist in the entire nucleus, and completely surrounding the nucleus in the orbit, electrons revolve, electrons move around. Clear? Now, observe carefully. When I concentrate on the atom, if I take an atom, clear? This is the atom. This is nucleus. This is an orbit. Okay. This is nucleus. Okay. And this is an orbit. And in the orbit, all the electrons move. All the electrons move. Here, and in the nucleus, there are protons and there are neutrons. N stands for proton, N stands for neutron, and P stands for the proton in the nucleus. Nucleus is the core part of the atom. Clear? Now, if I need complete the entire atomic mass, if I need, I concentrate on the nucleus, which is the core area of the atom. Understand? I concentrate on the nucleus, which is the core area of the atom. If I need the atomic atom's mass of an atom, if I require, I concentrate on the core area. Core part is which? Nucleus. Nucleus is the core area. I concentrate on the core part nucleus. What are present in the nucleus? Nucleus, protons are present, neutrons present. Hence, the total atomic mass is nothing but the mass of protons plus mass of neutrons, which are existing in the central core part nucleus. Clear? So here I write clearly that atomic mass, atomic mass of an atom, atomic mass is equal to, I am concentrating on the entire nucleus. In the nucleus, protons and neutrons are there. So complete mass of protons plus mass of neutrons. We do not take electrons. They are in the orbit. We concentrate only on the inner core part nucleus. So entire mass of atomic mass of an atom is equal to mass of protons, MP, plus mass of neutrons. This is the basic fundamental aspect. Basic fundamental aspects. Clear? Okay. Now, let me explain this concept by taking an example. I would like to take an example. I want to explain the atomic mass. Example, if I take example, okay, I am taking oxygen atom. Oxygen atom. I am taking oxygen atom. And in the oxygen atom, entire oxygen atom, notation is O. Notation is O. Atom. One atom, I am taking atom, oxygen atom. Okay. If I require the atomic mass, if I require the atomic mass of this oxygen, atomic mass of oxygen atom, atomic mass of oxygen, then in the entire oxygen atom, in the nucleus, mass of protons present in the oxygen atom nucleus, mass of neutrons present in the nucleus of oxygen atom. What is total atomic mass? Just now we have seen. We are concentrating on the nucleus. So here oxygen atom we have taken. So nucleus of an oxygen atom. In the nucleus of an oxygen atom, the mass of complete protons plus mass of neutrons. Now, how many oxygen atom, how many protons are there? How many neutrons are there? There are 8 protons. Okay, we have seen the atomic number is the atomic number. That is the, we are concentrating. So there are 8 protons and there are 8 neutrons that are present. Clear? 8 protons and the 8 neutrons. And there are 8 electrons revolving around the nucleus orbit. Clear? So here there are 8. There are 8 protons. So once there are 8 protons means 8 into mass of each proton. Mass of each proton. Plus there are 8 neutrons. 8 into mass of each neutron. Okay. Here I clearly write. Here I clearly write that in oxygen atom, in O, oxygen atom, 8 protons, 8 neutrons, 8 electrons. Here, so in the nucleus only protons and neutrons were considered. Hence, mass of 8 protons, mass of 8 neutrons. Clear? Now, what is mass of 1 proton? What is mass of 1 proton? Mass of 1 proton is 1 AMU, 1 atomic mass unit, plus what is mass of 1 neutron? 1 AMU. Okay, and you know very well. Here I highlight. Here I highlight. 1 AMU is equal to 1.6, 1.67 into 10 to the power of minus 24 grams. 1.67 into 10 to the power of minus 24 minus 24 grams. This is one atomic mass unit. Here, one atomic mass unit is 1.67 into 10 to the power of minus 24 grams. G stands for grams. So mass of proton almost is equal to mass of neutron. Both are 1 AMU. So here, if I simplify this, atomic mass of oxygen is equal to 8 into 8 AMU plus 8 AMU, 16 AMU. 16 AMU. Clear? 16 atomic mass units. 16 AMU. Is it clear? Atomic mass unit is equal to 16 AMU. In reverse also we can write. Observe. If I take up 1 AMU is 1 by 16th of atomic 1 by 16 of atomic mass of oxygen. Atomic mass of oxygen. Just I have taken reverse. 1 AMU can also be expressed in terms of oxygen atomic mass. So 1 by 16 of atomic mass of oxygen. Is it clear? No. What is atomic mass of oxygen? Mass of 8 protons plus mass of 8 neutrons. Mass of neutron is equal to mass of proton, that is equal to 1 AMU. Total 8 plus 8, 16 AMU, 16 atomic mass units. If I want to express one atomic mass units in terms of oxygen atomic mass, 1 by 16th of atomic mass of oxygen is equal to 1 AMU. Is it clear? Okay. Now, let us apply this to the concept of mole. Here, mole concept I am introducing. Mole concept introducing. Okay. Now, observe carefully. I need 1 mole of oxygen, 1 mole of oxygen atoms, 1 mole of oxygen atoms is equal to how much? 1 mole of oxygen atom is equal to how much? See, direct, straightforward question. 1 mole, already you know. What is mole? 1 mole is equal to Avogadro number, 6.022 in 10 to the power of 23 number. Now, the direct question here is 1 mole of oxygen atom is equal to how much? Clear? Okay. Now, observe carefully. Atomic mass of oxygen, is equal to just now we have seen how much? 16 AMU atomic mass units. 16 AMU. That means 1 atom of oxygen mass is 16 AM. In 1 mole, how many number are there? In 1 mole, Avogadro number of quantity is present. That means 6.022 into 10 to the power of 23 numbers are there. Okay, here I clearly write. Here I clearly write. One atom of oxygen is 16. In 1 mole, how many number are there? In 1 mole. Okay, 6.022 into 10 to the power of 23 numbers are there. Okay, we need what is the atomic 1 mole of oxygen atom is how much? The direct question. That means these many quantities of oxygen atoms are present. 1 atom oxygen consists of 16 AMU. Then these many, in 1 mole, these many are present. Then how many? Just a simply multiplication. Observe carefully. One atom of oxygen, 1 atom of oxygen is equal to 16 atomic mass units. Here. Now, 1 mole. 1 mole here is how much? 1 mole is 6 point bracket. I am writing 6.022 into 10 to the power of 23 number 1 mole of atoms of oxygen is equal to consists of how much atomic units? Just cross multiply this. That is equal to 6.022 into 10 to the power of 23 into 16 AMU. 1 mole of just cross multiplication. Just cross multiplication here. 1 atom of oxygen, don't get confused. 1 atom of oxygen having 16 AMU of atomic mass. 1 mole. In 1 mole, how many are there? Avogadro number of atoms of oxygen will consist of how many atomic mass units? So 6.022 in 10 to the power of 23 into 16 AM. Okay. Observe carefully. We already know that 1 AMU is equal to, this is 6.002 into 10 to the power of 23. 16. 1 AMU is equal to 1.67 into 10 to the power of minus 24 grams. Just now we have written here 1.67 into 10 to the power of 24. This is 1 AM. This is 1 AM. I am replacing that. Now, if we simplify this, okay, this 6.00022 in 10 to the power of 23, this one multiplied with this one. Or if you simplify that, it becomes 1 in number. So completely is equal to 16 grams. 16 grams. Be careful. This is 16 grams. This entire thing 6.002 10 to the power of 23 into this quantity becomes 1, and 16 number only left, 16 into grams, 16 grams. That means 1 mole of oxygen atoms consists of 16 grams. I write here. 1 mole of oxygen atom is equal to is equal to 16 grams. 16 grams. This 16 gram is known as gram because it is expressed in the grams. Gram, since it is atom, we are concentrating only on the atom. Gram atomic mass. Gram atomic mass. In shortcut, we note it as GAM. Gram atomic mass unit. Okay, that means year afterwards, 1 mole of oxygen atom is equal to simply 16 grams. Gram atomic mass. Wherever you come across gram atomic mass, 1 mole of oxygen atoms, gram atomic mass 16 grams. Is it clear? Let us take up another example also. Let me take up another example, example number 2. Okay, I am taking carbon atom. Carbon atom. Okay, and observe carefully. Carbon atom consists of 6 protons, 6 protons, 6 neutrons, and 6 electrons. 6 protons, 6 neutrons, 6 electrons. We want atomic mass of carbon. That means single atom, carbon atom. Its atomic mass I need. So if I write over here, atomic mass of carbon. What is atomic mass? In the nucleus, what are the present? 6 protons are present, 6 neutrons are present. So mass of protons present in the nucleus of carbon atom. Mass of neutrons present in the nucleus of the carbon atom. Now, how many protons are present? 6 protons. So 6 into mass of each proton plus how many neutrons are present in the carbon atom? Nucleus of the carbon atom? 6. 6 into mass of neutron that is present in the nucleus of carbon. That means here 6 into mass of proton is equal to 1 AMU into 1 AMU, 1 atomic mass unit, plus 6 into mass of neutron is also 1 AMU, 1 AMU. So on simplification, this becomes 12 AMU, 12 AMU. Clear? So here I write atomic mass of carbon. 1 carbon atom mass is 12 AMU, 12 atomic mass units. 12 atomic mass units. Clear? Is it clear that one? 12 atomic mass units. Okay, mass of 1 carbon atom. Now I can express in the reverse also. 1 AMU is equal to 1 by 12 of atomic mass of carbon. If I want to express atomic mass unit in terms of atomic mass of carbon, if I want to represent atomic mass unit, 1 single atomic mass unit in terms of atomic mass of carbon, I take reverse. 1 atomic mass is equal to 1 by 12th of atomic mass of carbon. Is it clear? Okay, fundamental aspects. Okay, now observe it. Now I require 1 mole of carbon atoms is equal to how much? 1 mole of